You are listening to The Vocal Technologist. Spoken tech for your ears.
If you're anything like us, sometimes it feels like you need a degree in future studies just to keep up with what happened, last Tuesday?
Oh, absolutely.
The pace of tech right now, it just doesn't feel linear. It feels exponential.
Like the whole world is accelerating at orbital velocity. It's true. And that speed, that sort of blinding speed, is exactly why we craft these sessions.
To give you a coherent picture.
Exactly. We're not just tracking the news. We are trying to identify these pivotal technological tipping points that are defining the next decade.
All at once, too, across completely different fields.
Right.
And that's really the mission for this exploration, isn't it? We're doing a full spectrum analysis. We're going to tackle the hyper-competitive battles in AI, you have the software models, the OEs we use every day. Then we'll pivot to the actual infrastructure wars, high in space, deep underground. And then we'll end on, I think, the most intimate frontier.
The human body itself.
Yeah, these breakthroughs in science that are literally changing how we define our own minds and bodies.
And we've organized the material to try and get some clarity to that chaos. We'll start with the models and the hardware, the new frontier of software.
Yeah, okay.
Then we'll move into the infrastructure needed to run it all. And like you said, we'll conclude with the ultimate operating system. As we sometimes talk about on Vocal Technologist, the challenge is always focusing not just on the what, but on the why.
The strategic implication for you.
Exactly.
Okay, let's jump straight into the AI battleground, because the pace of iteration, I mean, it is just relentless. We should start with Anthropic. They just released their latest model, Opus 4.5.
Right.
We know it's showing huge improvements, especially in coding and general reasoning. But I think the real story is their business model.
It's a brilliant tactical move. The strategic shift here is making that top-tier performance radically more affordable.
Radically.
They've slashed the API costs down to $5 per $1 million input tokens and $25 per $1 million output tokens.
Which at scale is everything.
When developers are scaling up their apps, that pricing difference is what keeps an entire company solvent. It's huge.
But okay, cost aside for a second, what's the novel feature for developers that we really need to understand here?
That would be the new effort parameter.
Okay.
Think of it this way. When you run a powerful AI model, you don't always need its absolute maximum capability for every single query.
Right. Sometimes it's a simple summary.
Exactly. Or it could be a highly complex multi-step coding sequence. The effort parameter lets developers explicitly tune that dial.
So they can balance efficacy and token burn.
Precisely. They get precision control over their budget and latency, which has led a lot of people in the developer community to call this the coding model we've been waiting for. It solves a core problem of waste.
That is a serious power move. And it immediately puts pressure on Google. And they're certainly not sitting still. We've seen major updates to the Gemini 3 API. What's Google's countermove?
So Google is focusing less on efficiency, it seems, and more on pushing the boundaries of capability.
Pushing the edge.
Right. The Gemini 3 updates are leveraging its core strengths in reasoning and multimodal understanding, but they are critically focused on agentic capabilities.
Okay, let's pause on that word. Agentic. It gets thrown around a lot. For someone who doesn't live inside an LLM, what does that actually mean?
In simple terms, it means the model can act autonomously.
Okay.
It's not just generating text, it's reasoning through a multi-step task, planning the steps, executing them, checking the result, and then correcting itself until the job is done.
I see.
And these API changes are designed to give developers the hooks they need to manage that whole autonomous workflow. So they get much more control over how the model reasons, how it processes video and audio, and most importantly, how it securely interacts with the outside world.
Another app, a database, whatever.
Exactly. It's a leap toward truly useful AI workers.
So if the software is getting that much better, the next front in the AI war has to be the physical hardware. We've been hearing these rumblings about OpenAI getting into the device game.
And that's confirmed. Sam Altman has said the first hardware prototypes are finished.
Wow.
And the company plans to reveal a dedicated device in 2 years or less. This is not a subtle move.
No, it's a direct challenge.
The implication is clear. OpenAI believes the future of interacting with its agents needs a completely optimized hardware and software stack that, existing device makers just aren't providing efficiently enough.
That's a bold gamble, though. I mean, history is littered with tech companies that thought they could redefine hardware and failed miserably. Why take this threat seriously against, say, Apple?
Because the entire interaction paradigm is shifting. It's being watched so intensely because a successful vertically integrated device from OpenAI could fundamentally threaten Apple,
Right.
which ironically has been criticized for being, well, slow and cautious in integrating its own AI features into its operating systems.
So OpenAI is betting that a device designed only for this agentic future will win out?
Exactly. Win out over a general purpose phone that tries to just bolt AI features on top.
And speaking of operating systems, Apple isn't the only giant making huge structural changes. We're seeing this massive convergence with Google's Aluminium OS project.
Yeah, that sounds like a Frankenstein's monster of software, doesn't it?
It really does.
But it's ambitious, and you can see why it's necessary. This is the unification of Chrome OS and Android into a single desktop platform.
A single platform.
And the strategic goal isn't just convenience, it's computational gravity. They're pulling all their resources into one place, centered around a deep integration with Gemini at the core.
So it's baked in from the ground up.
The deepest layers of the OS, whether you're on a laptop, a mini PC, a tablet, it's a monumental effort to establish desktop dominance and create that seamless bridge between mobile and desktop that, frankly, Windows and macOS still struggle with.
That transition from, virtual code to physical computation,
Mm-hmm.
that brings us perfectly to the infrastructure wars.
Mm-hmm.
Because none of this powerful software works without a massive global foundation. So let's unpack the competition in space internet.
The low Earth orbit, or LEO battle, is definitely heating up. Starlink has had the field pretty much to itself for a while.
For sure.
But now Amazon is challenging them head-on with Project Kuiper. They've just opened up their beta tests, focusing on enterprise customers first. And the promise is revolutionary. Gigabit satellite internet speeds.
So for someone who isn't familiar, what's the strategic advantage of LEO compared to the traditional satellites we've had for decades?
It all comes down to latency.
The delay.
Exactly, the time delay.
Yeah.
The old GEO satellites are so far away that the lag makes things like video calls or online gaming challenging. But LEO satellites orbit much, much closer to Earth.
So the signal travels faster.
Drastically reduces the latency, yeah. It makes the internet experience feel much more like fiber optic cable, but with global reach. Kuiper is trying to prove they can match Starlink on reliability and beat them on speed.
And what are the specifics on the hardware they're offering?
So the dish they're touting, the LEO Ultra, is promising speeds of up to 1 gigabit per second download and 400 megabits per second upload simultaneously.
Wow.
It's incredible performance. They're expecting a wider commercial rollout next year, which really solidifies space as a genuine utility, not just a novelty.
And staying in space for a moment. Let's look at the sheer muscle required to launch all of this.
Yeah.
The super heavy lift market, dominated by SpaceX's Starship, is about to get a serious rival.
It is. Blue Origin wants a piece of that action.
And they are scaling up fast.
They are. They're introducing the new Qwen 9x4, which they are explicitly marketing as a super heavy version. It's a sheer volume play. This rocket is designed to deliver a staggering 70 metric tons to low Earth orbit.
70.
And a hefty 20 metric tons all the way to the moon. This kind of capacity is just essential for building permanent lunar infrastructure or launching those huge satellite constellations we were just talking about.
So we've gone from orbit all the way down to the subsurface. The Boring Company is making headlines, not just for digging tunnels, but for changing the fundamental economics of it.
This is a truly disruptive idea. It's centered around their new Prufrock 5 tunnel boring machine, or TBM. To get why this is a big deal, you have to understand the traditional TBM life cycle. They are massive, complicated, incredibly expensive to build, and then once the tunnel's done, getting the machine out of the ground is often just prohibitively costly.
So what do?
Most standard TBMs are simply abandoned underground.
Wait, really? They just leave hundreds of millions of dollars of complex machinery buried forever.
Exactly. It's astounding inefficiency. The cost of retrieval is often more than just building a new one, but the Prufrock machines are designed differently. Their really disruptive feature is reusability.
So they can get them back.
They're designed to be retrieved, upgraded, and deployed again. The company's goal is for these machines to be as reusable as SpaceX's rocket boosters.
Which would change everything.
It would make the cost of underground infrastructure plummet.
That physical scale is just mind-boggling. And yet it all comes back to the computational appetite of AI.
The insatiable demand.
The scale needed for these models requires infrastructure that is doubling every few months.
It's the strategic imperative driving all of this. Google's AI infrastructure boss made a chilling statement. He said they must double their AI serving capacity every 6 months just to meet projected demand.
Double. Every 6 months.
And the long-term goal is even more astonishing. Achieving 100,000x capability, compute, and storage for the same cost and power consumption in 5 years.
1,000 times.
That kind of scaling isn't incremental. It means every single efficiency we've talked about, from cheaper tokens to reusable tunnel borers, is now vital just to stay in the game.
That massive shift in scale brings us to a harsh reality check for everyone building software right now. There's a concept in the material called technical deflation.
It's a vital concept for the modern builder to understand. Technical deflation basically acknowledges that anything you, the developer, build today will be easier, faster, and cheaper to build in 6 months.
Thanks to those cheaper tokens and better AI models we just talked about.
Exactly. Your competitive advantage is melting away beneath your feet.
So what does that actually mean for strategy? I mean, if building technical features is no longer the moat, where should entrepreneurs focus their energy?
The core insight is that the moat has to shift from the how to the why.
Right.
You can no longer base your advantage just on having built some complex piece of technology. It must shift entirely to selling, understanding your customer, and solving their problems better than anyone else. Your unique insight into the market. That is the non-deflating asset.
The tech tools themselves are just becoming commodities.
Pretty much.
And this difficulty is especially true when engineers try to integrate these flexible AI agents into their systems.
Yeah.
It really highlights a clash of worldviews.
It raises a crucial question about training, I think. Traditional engineers are trained on deterministic systems.
Meaning, what? Like a recipe?
Exactly like a recipe. You put in X ingredients, you follow Y steps, and the result is guaranteed to be Z. You have total certainty.
Right. If my code says if X then Y, Y has to happen.
Always. But AI agents rely on probabilistic systems. That's more like asking a chef to make something delicious. You trust the outcome will be a great meal, but you understand the exact steps might change.
Based on the ingredients or the customer's mood.
Right. You trade certainty for semantic flexibility. And trying to force an agent into a deterministic box just defeats the entire purpose of the agent. The successful ones, like the post-hoc AI agent we saw, embrace this. It works tirelessly in a loop to do multi-step tasks like writing SQL queries or setting up new feature flags.
And it works precisely because it can handle that ambiguity and course correct.
Exactly.
That contrast between rigid systems and flexible intelligence is a great bridge to our final section. Let's leave the world of code and infrastructure for a moment and look at the ultimate system we're all trying to understand.
The human operating system.
Right.
The scientific advancements here are just staggering. We have a genuine medical triumph. A world-first gene therapy halting Hunter syndrome in a 3-year-old boy.
And to be clear, Hunter syndrome is a type of childhood dementia.
It is. It's devastating. And most patients tragically die before they turn 20.
And the treatment was successful.
A year after treatment, the boy is developing normally. It's a massive shift in how we approach genetic disorders, moving from just managing them to, well, an actual functional cure. This kind of research fundamentally changes the limits of human potential.
And then on a completely different and slightly bizarre note, we're even learning how to manipulate our senses, specifically smell.
I find this absolutely wild.
It's the mind-bending side of science. Scientists used focused ultrasound, targeted directly at the olfactory bulb, which is tucked right behind the nose, to induce the sensation of smells.
Wow.
They successfully induced the feeling of fresh air or ozone, and less pleasantly, things like garbage or burning wood.
I have to wonder why anyone would target the garbage smell first.
I was thinking the same thing. But seriously, what's the application here? Why increase the bit rate of smell?
Well, imagine therapeutic applications where smells could treat PTSD, or virtual reality environments that are just far more immersive. If you can reliably trigger a precise sensation, you've unlocked a whole new layer of human interaction.
And potentially deep cognitive therapy.
Right.
Finally, let's zoom out to the whole brain. Researchers have mapped the development of the adult human mind, and the findings really challenge our traditional timelines for maturity.
They've mapped 5 distinct eras of the brain's journey, marked by 4 pivotal turning points. But the crucial insight, I think, is that adult mode does not actually start until the early 30s.
The early 30s?
Around age 32. For years, we defined adulthood much earlier, but this mapping shows that the most significant wiring and structural consolidation of the brain's networks isn't finished until well into the third decade of life.
And why does knowing that precise timeline matter?
It helps us pinpoint exactly when the brain is most vulnerable to disruption.
Let's see.
If we know that deep structural refinement is happening well into the late 20s, that knowledge can guide intervention and prevention strategies, especially during those tumultuous adolescent and early adult periods when many mental health disorders first emerge. It refines our whole understanding of what human maturity actually is.
So if we synthesize everything we've covered, the picture is one of just ferocious multi-front competition.
Absolutely.
You've got Opus forcing price wars, Amazon and Starlink fighting for global bandwidth, Blue Origin trying to scale launch capacity. The entire foundation of technology is just constantly shifting underneath us.
And that shifting ground reinforces that point about technical deflation, doesn't it?
It does.
The raw capacity is increasing exponentially, which means you need to shift your focus. The value is migrating away from knowing how to build the tech toward knowing how to apply that power, and, most critically, how to think strategically about the implications.
We spent time discussing how engineers need to design better probabilistic systems for AI agents. But the material also forces us to consider how we design our own focus.
In this world of accelerating change, yeah.
We know that deep, creative work is mathematically rare. So if just dropping one interruption per hour per day can completely transform your week, reclaiming hours of deep work, what deliberate design choice are you going to make today to reclaim your focus? That knowledge about ourselves, about our cognitive limits, is just as critical as knowing about the latest frontier model or the newest rocket launch.
Spoken Tech for your ears.